In this video, I'm going to show you how to use the TI nspire to solve normal probability problems the easy way. So first, let's review. The normal PDF looks like this. It is a function of x, and it contains two parameters, the mean value and the standard deviation. And this is a shorthand notation for that normal random variable with mean mu and standard deviation sigma. And depending on the values of mu and sigma, we can have different looking curves. Okay, for example, curve B has a smaller standard deviation than the red curve. However, their mean values are the same. And then you can shift the curve by simply changing the mean value. Okay, for example, curve C has a bigger mu, but the same sigma as the red curve A. Now, usually you have to transform the problem into that for a standard normal distribution, which means it has zero mean and unit standard deviation. So this is the standard deviation, this is the mean value, and then all probabilities concerning such a normal or standard normal variable can be obtained from table lookup. So this big phi of A means the probability going from negative infinity all the way up to A. What are the chances that a standard normal random variable assumes a value anywhere below A, and it's given by this integral, and this is how we write it. And let's see how we can actually do it easily. So turn on your calculator and insert a new document, which in this case is a calculator page. And for the standard normal CDF, we can press the book key. I call this the book key. And under N, okay, you can press the N letter first, and then you can use the control 3 function to quickly scroll down to the normal CDF command. What does it do? It would give you a probability. Okay, if you do not specify these two optional quantities, mu and sigma, then it assumes that you are looking for the standard normal probabilities. Then you just have to give it lower bound and upper bound. Okay, so in this case here, the lower bound of course is negative infinity. Okay, so let's pick the command, and the negative key is here, which is different from this, which is the subtraction key. So negative, and where's infinity, you can find it under the pi key. Use these arrows to help you navigate. Negative infinity is the lower bound, going up to 0. Well, but we all know that it's expected to be half, or 0.5 probability. Okay, so let's press enter. Yes, indeed it is 5. And you can always use the arrow key to go up and copy a previous input and enter to copy it. Now we want to go up to 1, which should give us more probability, right? So because going up to here you get 0.5. If you go further, I expect to pick up more probability. In fact, about 0.84. Okay, what about going to negative 1 instead? Well, then we expect to have something less than 0.5. Okay, so change that 1 to a negative 1. Okay, and we do get 0.1587 as seen in the hand computation involving table lookup, of course. But we can save ourselves a lot of trouble, okay, using the calculator. Now let's see how to go the other way around. Okay, if you are given some prescribed probability and you want to know where on this standard normal curve, okay, do I need to go up to? So A is the unknown in this case, but the probability, the shaded part, is known. So how do we do that? Okay, well, you can try to look it up from a table, or there's a much easier way on the calculator. So this is the inverse operation. So we press the book key and press I, to find the inverse normal command. Okay, INVNORM. What it does, okay, look at the hint here. Input the area. I can skip the mean and sigma, so it will give you simply the x value you need to go up to from minus infinity, of course, in order to get the prescribed area. So let's press enter. Okay, and for example, if you wish to get 0.5 probability, what what x value do you need to go up to? Well, obviously you go up to 0. Okay, and we can copy that command, but change the input. What if the prescribed probability is 8, 0.8413 for 5? Okay, you can highlight that and copy the exact number. We expect to get 1 as the answer. In fact, it is. Okay, so similarly, you can use this command again and verify that, for example, in order to pick up a probability of 0.1587, which is very close to this number, the expected answer is very close to -1, but not exactly, okay, because this number is not um, that exact. So it is actually very close to -1. Okay, so that is the answer approximately by hand. Okay, and table lookup. Now let's do some probability calculations. Suppose we have a normal random variable that has a mean of 200 and a standard deviation of 30, and we wish to know the probability of its being between these two values. Okay, so again we press the book key and we want a normal probability, so control 3 to find the normal CDF command. And this time we really do have some finite lower and upper bounds, being 230 and 260, separated by a comma. Okay, and we know the mean value is 200 and the standard deviation is 30. So you can simply do that. Okay, instead of having to standardize things and then look up things in a table twice and some algebra. Okay, we can save ourselves all that work by using the norm CDF command. Okay, lower bound, upper bound, mean, and standard deviation. So I think this saves you a lot of time compared to the hand approach or by hand approach. Okay, now let's do an inverse problem. Okay, what if I know the standard deviation and mean value, and I know that, or I need to fix the probability to 99% for this event, that the variable is no more than a certain value. What is that certain value? Okay, so that requires some equation solving. You can do it by hand, or you can just use the equation solver here, book key, and the S until you find the solve command. I think you need control 3 times, and one more arrow down. You will find the solve command, which solves equations with variables inside. So enter. So what is the equation? Okay, the equation is basically this. Okay, how do we write that on the nspire? Well, we just wrote this thing, right? Except now we don't really have a determined upper bound, and the lower bound, of course, is -infinity. So let's use that command again for the normal probability. Okay, norm CDF. The lower bound is -infinity in this case, and we will allow it to go up to some unknown value, f. Okay, of course the standard deviation and mean are known, 200 mean and 30 is the standard deviation. Okay, now that probability has to be equal to 0.99. That completes our equation. Okay, so from here to here is our equation. Notice there's this equal sign involved, comma. Now you must supply the unknown, okay, which is f, because in an equation there could be other coefficients that are symbolic, so you need to tell the calculator exactly what you're looking for. So press enter, and the solution comes out immediately. Okay, I think that's a very direct approach compared to all these hand computations.